Hey everyone, Linus here. Today we're diving into a hot topic, literally. We're talking about smartphone thermal management, or how our phones stay cool under pressure. With each new generation, smartphones pack more power into smaller spaces. This means more heat, which can lead to performance throttling, reduced battery life, and even discomfort for users. But fear not. Manufacturers are constantly innovating to keep our devices cool and running smoothly. From clever software tricks to cutting-edge materials, there's a lot that goes into keeping your phone from turning into a hot potato. So let's break down the challenges of smartphone thermal management and explore the cool solutions that are keeping our devices running at their best. So why do smartphones get hot in the first place? It all comes down to physics. Smartphones are essentially tiny computers that generate heat as a byproduct of processing data. The more demanding the task, the more heat they produce. Think about playing a graphically intensive game or streaming high-definition video. These activities push your phone's processor and graphics chip to their limits, generating a significant amount of heat. Add to that the ever-shrinking size of smartphones, which leaves less room for heat to dissipate. And you've got a recipe for a toasty device. To cram more components into slimmer designs, manufacturers have turned to dual and triple stack PCBs or printed circuit boards. Imagine a layered cake, but instead of frosting, it's packed with processors, memory chips, and other essential components. While this stacking technique saves space, it also creates a thermal challenge. Heat generated by one layer can easily transfer to adjacent layers, creating hotspots that can impact performance and longevity. Think of it like stacking hot pancakes. The more you add, the hotter the whole stack gets. One way to combat smartphone heat is through clever software optimization. Developers can implement various techniques to manage heat generation and keep your phone running smoothly. One common method is dynamic voltage and frequency scaling, or DVFS. This technology dynamically adjusts the processor's voltage and clock speed based on the workload. When the phone is idle or running simple tasks, DVFS lowers the voltage and frequency, reducing heat output. Another approach is CPU hot plugging, which selectively deactivates CPU cores when not in use. This reduces power consumption and heat generation, especially during light workloads. Section 5. Hardware solutions, beating the heat with design. While software plays a crucial role in thermal management, hardware design is equally important. Manufacturers are constantly innovating to improve heat dissipation and keep our devices cool. One common hardware solution is the use of heat spreaders, typically made of materials like graphite or copper. These materials are excellent thermal conductors and help to distribute heat away from hot spots, allowing it to dissipate more effectively. Another approach is to incorporate heat pipes or vapor chambers into the device's design. These components utilize a phase change cooling process, where a liquid absorbs heat and vaporizes, carrying the heat away to a cooler area where it condenses back into a liquid. Section 6. Material matters. The future of heat dissipation. As smartphone components become more powerful and compact, traditional thermal management materials may not be enough. That's why researchers are exploring new materials with even better heat dissipation properties. One promising material is diamond, which boasts the highest thermal conductivity of any known material. While expensive to implement, diamond could revolutionize smartphone cooling if production costs can be reduced. Another contender is graphene, a one-atom-thick layer of carbon atoms arranged in a hexagonal lattice. Graphene exhibits exceptional thermal conductivity, surpassing even copper, and could pave the way for thinner and more efficient heat spreaders. Section 7. Future trends, a cool look ahead. The future of smartphone cooling is looking bright, with exciting new technologies on the horizon. One promising area is microfluidic cooling, which involves circulating a liquid coolant through tiny channels within the device. Imagine a miniature version of your PC's water cooling system, but integrated directly into your smartphone. Another exciting development is the use of artificial intelligence for thermal management. AI algorithms can analyze device usage patterns and predict heat generation, allowing for proactive cooling adjustments. Section 8, conclusion. So there you have it, a glimpse into the world of smartphone thermal management. It's a complex and constantly evolving field, but one that's crucial for ensuring the performance, longevity, and user experience of our beloved devices. From clever software optimizations to cutting-edge materials and cooling techniques, manufacturers are pulling out all the stops to keep our phones cool under pressure. And as technology continues to advance, we can expect even more innovative solutions to emerge, keeping our devices running smoothly for years to come. Section 9, disclaimer. The views and opinions expressed in this essay are those of the author and do not necessarily reflect the official policy or position of any agency, organization, employer or company.